Good morning, everybody. Good morning, everybody. We have finished already sucker rod pumping system. Sucker rod pumping system is a positive displacement type pump, and today we are going to start electric submersible pump or ESP. ESP basically a centrifugal pump, and centrifugal pump connected in a series. It will create a multi-stage centrifugal pump, and if you are submerging in liquid, then it will be calling as submersible pump. Electric, why? It will be run by electric motor, so it is called electric submersible pump. Three terms are there. Electric means you have electric motor, you cannot use IC engine inside wellbore, you have to use motor only, and submersible, it must be submerged in liquid, and pump. And if you are not submerging, then there will be some issue related to priming. That's why and again NPSH also will be playing a role, so that's why it is submerge in liquid and start pumping. That will be good for your wellbore. If you see any electric submersible pump, first let's see one wellbore. Okay, this is your casing cemented, then you have perforations and you have reservoir, right? So fluid, liquid, gas, water, sand, everything will be entering, and if you have proper sand control mechanism, the sand will be lower, and if well is completed properly, then water also will be lower, and if you are changing suddenly production rate, then water or sand may come into your wellbore. So that you have to avoid water or sand, because both will take your money, but it will not generate any revenue. So you have to get oil and gas, and if you are using ESP, then main purpose will be to produce oil, and gas anyway it is low density fluid, so it will be coming out to the surface. But if gas is interfering ESP, then there will be problem. So how this ESP look like in tubing? This is my tubing. Let's put on packer. Okay, then one cable will come and my pump is here. Okay, pumping system. So pumping system will have one motor, so I'll write motor. Then there will be one protector section. Protector section, actually it will be protecting the motor. Motor is electrical unit, and if water or wellbore fluid is entering into your motor, then motor coil will be getting burned. So normal application you don't want to burn, because burning motor under this wellbore condition means you have to remove the whole system. That will be expensive affair. So you have to avoid inserting or injecting water inside the motor. Inside there will be transformer oil or motor oil, so that will be creating such environment inside motor, so that coil and magnet will not be touching each other, it will not burn or it will not create any spark. But if water is entering, dielectric fluid, so that will be creating a problem. So you have to avoid injecting water by mistake also through seal leakage or any other method. You cannot inject water. So for that we have one protector. Also not very small thing, it's very long as protector. Several seals will be there, so that no water will be entering, or motor oil or transformer oil inside motor, it will not come out. Then there will be one pumping unit. Intake will be here, maybe intake, pump intake will be here. Then you have one pumping area. Okay, so this pumping area, it will have a multi-stage centrifugal pump, and this fluid will be lifted to the surface. Okay, and one coil will be coming. That coil will be connected to directly to your motor. Coil or wire cable. It is not coil, it is cable. So electric cable. Okay, so electric cable will be controlled from the surface, actually how much power you are giving in which frequency. So when you got fluid on the surface wellhead, you take out the fluid. Okay, and then your cable will go to one section. So your cable will go to junction box, then it will go to switchboard, then from switchboard to your transformer, and transformer to your high voltage line. Okay. So, the purpose of transformer, if you have very high voltage, let us say 11,000 voltage, and you want only 440 volt for your pumping operations. So, you have to reduce voltage and you have to supply to motor. If you are giving 10,000 volt to your motor, motor will get burnt. Okay. At very high voltage, the system will fail. So, in transformer system, you are reducing step down transformer, you are reducing your voltage, then you are passing this on to switchboard junction box, that electric current will be moving towards your motor, then motor will be running, that motor shaft will be transferring power to intakes to the motor through protector intake section. So, protector is not giving any energy, actually it will be taking some energy because of friction, and pump intake means there will be lots of holes will be there. So, the fluid can enter into wellbore and through pump it will go to the surface, and surface there will be like wellhead, Christmas tree, MAS tree, and several valves, master control valve like primary, secondary. So, those controlling valves will be there. Okay. And if you are getting gas, then you have to use some gas separator. So, the gas separator, the separate will be separating gas and liquid, and the gas must be transferred through another line, maybe annular area you can use for taking out the gas from the wellbore. And if your ESP is facing gas, there will be multiple issues. Later we will discuss what are the different issues. Okay. So, then ESP is having basically a centrifugal pump. If you see these points, centrifugal pump, then will be seal section or protector. This is protector, and there will be electric motor. Normally this will be induction type motor, and power cable, already I said electric cable or power cable, and surface motor controller like transformer, switchboard, junction box will be there. There sometimes there will be variable frequency drive also to control pump speed. So, surface controlling or surface equipment will have like junction box, switch box, transformer. These are the surface unit, and very small unit like sucker pump you have very big unit on the surface, but in this case very small electronic circuitry will be there. So, this ESP can be used in any wellbore, offshore, onshore, deep water, does not matter. Okay. And ESP can go to horizontal wellbore also, like in sucker pump there is limitation, like it will be going vertically and maybe 5-10 degree deviation be okay. But in electric submersible pump, go vertical, go horizontal, go S-shape wellbore, go multilateral, does not matter, because it will be pumping irrespective of your direction, or it is vertical or horizontal or slanted. Okay. And ESP will have many other components also. For the holding device will be there, then there will be one sometime inducer will be there. Later we will discuss what is the inducer and other aspects. Okay. Now, okay, so why ESP? ESP is actually relatively higher velocity or higher fluid flow rate pump, and it will give a moderate head, but flow rate will be little bit higher than your sucker rod pump. Okay. So, flow rate Q is higher than SRP. Okay. In ESP we will have higher flow rate than SRP, sucker rod pump, but sucker rod pump can have infinity head. So, head is very high in sucker rod pump, but ESP will have limited head, but flow rate is higher. So, whenever you have higher flow rate, you will use this one. For example, you see this section, high flow rate like 150 barrel per day to 150,000 barrel per day flow rate also can be achieved, and that can be changed also using your VFD or other mechanism, but within this range normally flow rate will be there. But if you are trying to pump let us say 10 barrel per day, in that case I will suggest use sucker rod pump, because very low flow rate 10 barrel. But if you are going for let us say 1000 barrel per day, but 10,000 barrel per day, so definitely we will suggest to use ESP, not sucker rod pump, ESP or maybe other type of artificial lifting mechanism. And it is a multi-stage pump, and the motor type will be induction motor, 3-phase induction motor. We will discuss what is 3-phase, what is induction. And seal chamber section, seal chamber again I said like this is protector section, and power cable is there, and surface control unit will be there. So, these are the basic part of the ESP systems. And what type of ESP should be used for your wellbore. So, for that you have to go to specific speed formula. Already I told in some other lecture that specific speed means ns divided by n power root of q h 3 by 4. ns is specific speed, n is rpm of impeller. What is impeller I will discuss later. Impeller, okay, and q is a flow rate, and h head developed. Okay, so how much fluid it is creating, how much head is you are developing, that is h, and how much flow rate you are giving, so that is q, and n is the impeller speed. Okay, it is not motor speed, maybe motor speed will be higher, but impeller speed will be lower because of slippage, or maybe some other losses may be there, and that speed can also change. Now, this specific speed actually not non-dimensional number, it is having unit. So, whenever you specify specific speed, you have to give the unit. So, you see this n rpm, rpm is not cancelled out because only top portion rpm is there. Flow rate power q, so flow rate per, that also meter cube per second divided by 2, right, and h 3 by 4, that also meter. So, unit is not cancelled, so unit must be there. So, whenever you are saying specific speed and you want to represent in terms of curve, this like this is x axis, this is y axis. Okay, in x axis you put ns values, and this is efficiency value. Okay, if you go to lower specific speed, you are going to radial type impeller. I will explain radial type impeller later. I think in previous lecture also I explained, again I will explain there. And if you are going for higher flow rate, q higher, so you are going towards axial type system, and if you go further below of specific speed, then you can go for positive displacement type pump. Positive displacement type pumps like sucker pump, those, or PCP, those are positive displacement pump. Their specific speed will be very low, lower than your radial impeller. Okay, this is actually very tall blade impeller, this one, tall blade. This is a little bit lower, this will lower, this is mixed flow type. Okay, mixed flow type impeller, mixed flow, this is axial flow. Okay, so tall blade impeller, tall blade mistake, tall blade impeller, tall blade radial. Okay, tall blade impeller will be very long, and it is radial blade, and there will be mixed flow impeller, there will be axial flow impeller. Now, what is radial flow impeller? I have brought my impeller system. Actually, this is one impeller, you can see. Okay, and impeller is having flow path here, fluid will be entering and it will be exiting. There will be a shaft hole, like so this is my shaft, I am giving shaft here, shaft will be giving rotation to the impeller. Okay, when shaft is connected to your motor, when motor is rotating, your impeller will also be rotating. Okay, and impeller is very thin actually, it is radial flow impeller, so this is very thin. Okay, radial flow impeller, fluid will be entering axially, this is axis, parallel to axis, radial fluid will be entering, then it will take turn inside impeller blade and it will be going vertical, so it will be turning 90 degrees. So, that is why it is called radial flow, radially turning. Okay, not axial, this is axial, this is motor is connected here, fluid is entering here, fluid is coming here, entering here and going like this. Okay, this is called radial flow impeller. And if it is axial flow, then fluid will be entering, it will be moving directly. For example, you have wind turbine, the turbine is axial flow turbine. If you see the turbine will be here rotating, but fluid is going and going out also. This turbine is here and fluid is going and coming out. And if you see ceiling fan on the top of your head, maybe summertime all over India you are running this ceiling fan, the ceiling fan actually axial flow fan. Okay, axial flow fan property is that, or axial flow turbine property is that it will be delivering or handling very high amount of fluid. Okay, and head or pressure development will be very low. Okay, axial fan, it is just delivering certain amount of pressure. So if you take pressure above the fan and after the fan, the pressure difference will be maybe 0.1 bar. Okay, and wind turbine also, if you are rotating turbine, then pressure difference will be like less than 1 bar difference. Okay, but if you are using centrifugal pump, the pressure difference can be 5 bar also. Inlet pressure may be 1 bar, the exit pressure may be 5 bar. Okay, so that much or more than that also possible. So it will be giving very high amount of head. But if you are having axial flow system like ceiling fan, wind turbine, so that sort of system, those will have very lower pressure difference but very high volume flow rate. So some cases you are using high volume flow rate, for example ceiling fan, you don't want very high pressure or high velocity in ceiling fan, because if I am having very high velocity, that will be good, air will be blowing here and there, but it will be creating too much noise and you cannot work actually, there will be too much air flow. So, but in that case you need very high volume of airflow so that the whole room will be circulated properly. Okay, instead of centralized jet of air. But in wind turbine also very huge amount of air is coming and it is passing through wind turbine and turbine is getting energy. Okay, but if you are developing very high amount of head, for example you are delivering fluid to Burj Khalifa, that 134 building, or in your hostel building 3-4 floor, so in that case you need certain amount of head so that you can cross all the resistance and fluid can be lifted there. So normally centrifugal pump will be used. Okay, but sucker rod pump is used where low volume flow rate but very high pressure is required. Sometimes in engine some fuel injector will have sucker rod pump or positive displacement pump, you will have beam pump or SRP, those are positive displacement pump, they will be giving very high head and low flow rate. Pump curves. So I said very high head and low flow rate pump is centrifugal type. Okay, and low head, low flow rate and high head, it is reciprocating type or positive displacement type. Here one picture I have taken from one thesis, Bellary et al. Not thesis will be Bellary 2005 I 2015 IITM thesis, PhD thesis. Okay, he has done some experiment using this impeller. Actually this impeller, this is called impeller, this is centrifugal pump, part of centrifugal pump. So this centrifugal pump part develops certain amount of head or pressure. Using that one he has drawn this curve, so I just copied from his thesis. You see this H is here and flow rate is here. So it is not in field unit, it is in SI unit, because he was writing thesis, so he wrote in SI unit. So you see this H curve is here. If he extends, then it will go like this. Okay, he did not extend, he did not make maximum flow rate, so he calculated only for certain range. Then he got efficiency. Okay, yeah, so this is efficiency, this is efficiency, and this is your head and this is your power consumed by pump, that is called pump system curve. System curve means how much power it is taking, how much friction it is crossing, so how much energy, total energy it is being consumed by pump, that is this line is showing. Okay, and head I said like it will be like this, it actually it will be going and it will be 0 somewhere, so Q should be 0 somewhere. Okay, that will be absolutely open flow when there is no restriction in the exit valve, so you are getting maximum flow rate, so that is open flow. So that time your pressure on the pressure gauge will be lower. Okay, but if you are using positive displacement pump, if you are using positive displacement pump, let's say SRP, for example this is SRP. Okay, this curve will be completely vertical. Okay, HQ curve, SRP HQ curve for SRP will be vertical, but centrifugal pump HQ curve will be coming down to 0. Is this side y axis it will be touching, x axis also will be touching, but sucker rod pump it will be touching only x axis, y axis it will not touch. It will be touching only if the plunger and barrel there is big leakage, or travelling valve or standing valve there is leakage. If there is leakage, then this vertical line will be touching y axis. If there is no leakage, then ideally it will be producing infinite head. So, SRP ideally infinite head. It can produce infinite head. Flow rate limited. If your stroke number of strokes SPM is limited, like say fix 10 stroke. So, if you are having 10 stroke, it can develop any amount of head, except if you have leakage, plunger and barrel, some leakage you have calculated the form, you can remember this flow rate leakage proportional to dc power q into d divided by mu L. So, that formula if you remember, there small leakage means very high, small clearance means very high leakage will be there. Okay. If there is no leakage, ideally infinity head can be produced using sucker pump, but centrifugal pump it cannot do that, it is having limitation. So, to cross the limitation, we can use multiple stages centrifugal pump and we can get a very big head. Okay. But single stage it will have limitation. Best efficiency point. Okay. So, best efficiency, what is best efficiency point? You have eta and your efficiency is like this, Q and H. So, this is HQ, okay, this is eta. So, this is the best efficiency point, BEP. Okay, best efficiency point means where you are getting very high efficiency, and if you change a little bit flow rate left or right, your efficiency is going down, you can see. Okay. So, running your centrifugal pump at BEP is very difficult, because there will be so many variabilities like a restriction here and there, friction. So, what the pump design will be suggesting, you run within certain range, plus minus 10% of this BEP. Okay. So, this will be your operating range, plus 10, this is minus 10, this is plus 10, about 10% plus minus you can make. So, that will be giving operating range. Within that, if you are running, then your pump will be running very good condition. It will be consuming less amount of energy because it is highly efficient. But if you are going away, what will happen? It will not give highest efficiency. Next thing is that it can create cavitation, noise, vibration, even pump can fail also. So, your main purpose will be to run pump at BEP. But if your flow rate or other thing changing, maybe you can try with changing your pump speed. If you are changing pump speed, then flow rate and head and other parameter also can get changed. But at fixed speed, run pump at operating range only. At the same time, SRP, it is not having any operating range. Just you move, run your plunger, it will deliver. But very high stroke if you are giving, for example, instead of 5-6 strokes, if you are giving 20-30 strokes per minute, and very big rod is there, because the whole rod momentum because and elasticity, the rod pump or sucker rod pump can fail. Okay. So, if you have very slow speed in sucker rod pump, very long wellbore for deep wellbore, so it will be very good actually. But shallow water maybe speed may be high, but very deep wellbore and very long rod is there, like a 3-way cup rod is there, and you are running at very high speed because of its own load. Rod is having own load plus momentum of beam, walking beam, plus your gearbox, plus your V-belt system. So, whole momentum will be destroying in the whole system. So, your speed normally should be like 6 to 10. If you can get lower, it is okay, but if you are going higher, for example, more than 20 in deep, very deep wellbore, so in that case system can fail. But in ESP system, deep does not matter, because you do not have such thing. Only if you have very deep wellbore or very high head you are developing, delivery head is very high, in that case just you have to increase number of stages. So, that also will be difficult, but ideally you can generate any amount of head if you increase number of stages. Okay. So, whenever we discuss about ESP, we should define certain parameters. So, total power required to do specific brake horsepower. Brake horsepower means this shaft is connected to this one, okay, motor is here, okay. So to measure how much power it is taking, what we'll do, would be putting some brake here, and we'll measure brake how much energy it is showing, how much energy getting lost to stop this motor, okay. So that is called brake horsepower. So how much total energy is used by this impeller or this machine, okay. There is brake. So if impeller can stop completely, that means it is using all the energy given by motor, okay. And that, but normally motor energy will be higher than whatever it is consuming, so system will be running continuously. If this energy consumption higher than motor, then motor will not be able to deliver, so then motor can fail actually, okay. So in that case, motor power will be higher than your consumption energy. And if you are using some dynamometer and you are reducing the, you are forcing to stop, so that much it is consuming some energy. So that way the dynamometer people will be measuring brake horsepower, okay. It is, you are as if you are applying brake, and how much energy you are consuming when you are applying brake, okay. That is called brake horsepower. Brake horsepower formula is that QH, specific gravity maybe gamma, you can write 3960 into eta. Eta is efficiency and gamma is specific gravity. Specific gravity of fluid you are pumping, that may be water or oil. And efficiency formula is given, eta equals QH gamma into 100 divided by 3960 into horsepower, okay. How much brake horsepower you have applied, that is eta. So from this formula actually directly it is coming, okay, or BHP you can write. And 3960, the term is coming like linking HP feet pound per minute to US gallon, okay. So minute to second you are doing, and that's why this term is coming, okay. And pumping head calculation is, head is equals delta P 0.433, okay. H is in feet, del P in PSI. So you have to remember units every time. If you are forgetting unit, there will be difficulty when you are solving the problems.